Hi, in this demonstration, we're going to take a closer look at the knowledge model that powers the cyber review application. We're going to go into a bit more detail than we usually do in the demos. But just to get started, what I've done is I've started up a question here. I said, explain the significance of the note found on Darcy's computer. And just to give you an idea, this is that note right here, the very first item in the human intelligence. It says, an interview with Hamad Darcy retrieved a note from Darcy's computer from a hacker located at, and then we give the URL for that, or the IP address for the hacker that they came from, and then indicating a server, and we gave the name of the server is now listening to, and then we give the name of a malware endpoint. We talk about the malware endpoint, what operation it's part of, actually, and a little bit more information about it. But this is really the information. So Hamad Darcy is the person in question here. So I asked the question, and then the system went in, and it found all this other information that doesn't appear to be part of that piece of intelligence. Like we're talking about a certain malware endpoint. We know a lot more about it. We know that this malware can operate, modulate on and off switches of different components of this hypothetical reactor that we're playing with here. And it uses other information inside the graph to understand what's connected to what. So let's dive down a little bit into this story and understand what's happening. So if we go to the knowledge model, this is where we, instead of interacting with text, we're interacting actually with the structure of the information itself. So if I click on knowledge model, the first thing you'll see is usually a graph. If you were here before and you were playing around with it, it'll remember the graph that you were on last time. So I'll just bring the one up that have been working on. I'll show you how to recreate this, just to get a feel for it. But this is Neo4j Bloom that's basically running inside the application. So it allows us a whole bunch of functionality to be able to explore these graphs that we've built. So let me start off with some basics. How to clear the screen. Right now we've got Hamad Darcy here and some evidence about him. We're going to recreate this in a second. I'll show you how easy that is. So first, let's clear the screen. It's Apple delete, and then everything goes away. And then the way this works is you basically ask the system for certain types of nodes. So I could say people, person. So I click on person and then press enter. And I could filter it down to a smaller group, but this just brings back all the people in the graph. So I'll just show you what we can do from here to give you a sense of it. Like there's two different types of actors in here. There's these people here in yellow. These are informants. They're also people. So our system allows multiple labels. So for example, the person that was the subject of the last investigation is this gentleman here named Janok. And Janok really is sort of the cornerstone of the cybersecurity of the use case. This is a confidential informant that gets killed. And it looks like Hamad Darcy is the one responsible, or at least somehow involved. So Janok and Darcy are connected here. So let's find out how. So the first thing I'm going to do is I'm just going to pick Hamad Darcy. I'm going to pick Janok. I'm going to right click, and I'm just going to say dismiss everybody else. So now we're just down to two individuals, Darcy and Janok. So the first thing I want to do with Darcy, I want to see what Darcy's connected to. So one of the things, you click on Darcy, then just press Apple E, and that will expand it. Alternatively, you can right click, click expand, and it'll expand it. So I always start off with this. So this is Darcy, and it talks about the evidence Darcy's connected to. And we'll do the same with Janok. We'll just expand Janok. Janok's also connected to 4 nodes in the graph. And there they are. And it turns out that 3 of them actually, or some of these nodes are actually connected to Darcy. So you can see here, a highly reliable source, Janok, reports that Darcy may be financing terrorist operations. Another one talking about highly reliable source is indicating that Darcy's financing these, and it actually includes these bank account numbers. So if I right click on this, let's take a look at these bank accounts. So if I go to expand, I can say, show me the banks that are being referenced in here, and these banks show up. Now these banks, because we've also loaded this financial intelligence, we can actually just click on a few of these nodes, right click, and let's expand them a little bit. And this will show the transactions that happen to those, or with those bank accounts, provided I clicked correctly. There we go. Okay, so now we've got these bank accounts. I'll just this is where you start playing with the graph size. It starts to get big pretty quickly. So I like to move things around. So let's keep all the banking stuff up here. All these transactions here, just to let you see what these look like. These are those bank accounts that were mentioned in that piece of intelligence. And each one of these nodes are financial transactions. And right now it's showing you the time on it. I might not want to see the time. Maybe instead I just want to see on this financial intelligence, let's go and make the icon like a $sign. Let's make it a little easier to look at. How about, I don't know, we pick whatever icon you're most comfortable with. I know that looks pretty good to me. And instead of putting the date on there, let's put the amount transferred on that node. It's not really that interesting to see when it happened, although that might be interesting. So we'll just leave it like this for now. So we've got the bank accounts, how much was transacted. We can also see which bank it came from, to and from, for example, so you can start seeing where these transactions come from. But the reasoner's got access to all this, but that's just following that banking information. Okay, we'll go a little bit deeper now into this Darcy. So that basically sets up the use case. You can see there's Janok and Darcy and all the information that connects them. And you can follow any of these paths. But the one we're going to follow right now, because we're most interested in it, is this piece of intelligence right here. And if you double click on the intelligence, you'll see a little bit more about it. So you can see it's got a server IP address in there. It's got another IP address in there. There's names of firewalls, not firewalls, the names of malware endpoints in there. So let's just expand this intelligence. Let's take a look what else it's connected to. So this piece of intelligence turns out to be connected, of course, to that server that was in there. And the only reason we know that is because this is a server that we're monitoring in our DMZ. So we've also got this IP address in here and the name of this malware endpoint. So presumably we can follow any one of these nodes even further. Let's follow this DMZ one. So the idea here is we've got Hamad Darzi, there's this note, and they're talking about this server located here. So let's find out more about this machine. So if we expand it, now we have that server, and I'll move this around a little bit so we've got a bit more room on the screen, and we learn a little bit more about that server because we've expanded it. So we know it's a help system. The company that's servicing is called Aquachill Technologies. Looks like there's an internal firewall log there. There's another internal firewall log there and another one. So there's 3 internal firewall entries. So this machine is talking to something internally 3 times. And then we can see here there's this external firewall. So this is this machine talking to the outside world. Let's find out what happens when we follow that to the outside world. Why is this machine talking to an outside point? And if we open it, we can see that it's talking to this malware endpoint. So this piece of human intelligence told us, hey, take a look at we've got this control of this server. And sure enough, when we looked at the internal firewall logs, we can see that this server was in fact communicating with this malware endpoint. So taking a look at this malware endpoint, we come in and let's see what it might be talking to. There's a good chance it's talking to servers internally. So if I take these 3 nodes, and again, to select multiple nodes, just hold down the command or the Apple button, the command, and then right click and then expand. So we'll expand these points to see what servers they were talking to. And it turns out that it looks like there's been 2 communications with this 7676 server and 1 communication with this. So there's a chance that this server and this server have been compromised by this malware endpoint because this guy's talking to both of them. And we've got some human intelligence that indicates that this is a control server. So these are the 2 systems that are very critical. Well, how do we know what systems are in the whole network? Let's do that. If I pick on, let's say, this DMZ server, right click and you can see that it's also connected to this this facility called Barfu. And the idea, this is the name of the facility, the nuclear facility in this case. So I'm going to move it down here, and I'm just going to right click and expand it just to show you all the information we actually have stored about this one server, or this one location. So this one location turns out to have a whole bunch of machines in it, all these other critical servers and all these other machines in the DMZ, and only a few of them are involved in this investigation right now because it doesn't look like these other servers have been compromised, and they're certainly not talking to this other one here. However, these servers are all inside the same facility. Here we're just looking at these firewall logs to understand what's happening. But you can see here, this is really how to explore these different paths. So when the reasoner is reasoning, it's following these paths through the network to understand how things are connected. There's another part of the story also in this network that we might want to explore, that other IP address up here from that piece of information. We noticed there was this one server 1.61.80.33, and this is that side of the story. But then there's another one here indicating that possibly this is the person responsible for doing the malware, because it's got this IP address of a hacker. So let's find out if we know anything else out about this particular IP address. We could expand it, and it looks like, yeah, there is one other piece of information that we have about that IP address. So we come here, you can see how it is expanded, and you can see that this one here, there's extensive internet searches over a period in the vicinity of Banu, and there's a couple of IP addresses, and the one that we're interested in is also in that list. So let's just see how far this goes. We'll expand this piece of intelligence and see what else this is connecting to. So it looks like it might be it looks like it picked up, they were searching chlorine gas and weaponization effects. So this address may have put the malware on and also done some research into chlorine gas, which actually turns out to be, if I take this chlorine node in the graph and I expand it, this is a concept, and we can see there's other things that happened in this scenario that are mentioning chlorine gas attacks. And if you go into this part of the story, there's dates on here and everything. But one of these, if I just find the most important one right here, yeah. So this is the actual attack right here. So it looks like it's an attack on a grand mosque. It killed 27 people and injured 60. Detonated. So it's really getting into the details. And what we're finding here in this part of the story is we're finding that this hacker who is potentially researching chlorine gas may be responsible for part of this attack. And you can see there's some other information here around chlorine, where we can see that people detained 3 men. Potentially these are the same people that maybe were behind it. So there's pieces of this graph that connect together, but all these stories really connect together through language. And this is what we provide to the language model when it's reasoning. Okay, I'm going to show you another way to build some of these graphs to get a feeling for what's going on. This is just another technique. I'm going to start off with just people again. So starting off with persons, and we just show all the people. So these are all the characters in the story, so to speak. And these characters are all connected through evidence. So if we want to see how that works, one of the quickest ways to do it is just go Apple A to select everybody, or all, and then Apple E to expand everything. And because the way we do this system is all of these entities are connected through evidence. So like you can see here, there's this, you can see what's connected to what a little bit more closely. Like informants here are in yellow, people are in purple, and human intelligence is in green. So you can see this piece of human intelligence here has 3 or 4 people connected to it, but it's not connected to anything else. So it's kind of on its own. Whereas maybe this one here, this person here, turns out to be connected to this piece of intelligence, this piece, this piece. So let's find our characters that we're following. So we're following Janok and Darzi. So if we zoom in a little bit more to them, we can see how they relate to everybody else in the network. So let's take Janok, move this up here. And sometimes, and this is unknown, so these pieces of information, these pieces of intelligence, we don't actually know who the person is, but we're just treating unknown as a thing, because we may want to look at what evidence do we have where we don't know who is responsible for it. So let's just zoom in on one of these. So let's find that Darzi one here. That connects us back to the cyber attack. And this cyber attack here, it must be this one here, because this isn't connected to Janok directly. So what I'm going to do, just to simplify, this is a good little technique. If the graph starts to get too big, pick the thing you like and just zoom out and move it sort of to a space on its own, because we want to look at that graph. This graph here is really about how the people are connected. And this one little piece of intelligence here is that cyber attack. So let's just expand that. I'll show you another way to do it. So again, you select it with, you click on it, and then Apple E, or you just right click on it. So that's going to expand that node. And it's going to get quite messy here, so I gave it a lot of space. So I'm going to go and expand that server, move it down. I'm going to expand this Barfu facility, because that's really the facility this server is in. Now you can see things are getting a bit messy again. So let's just clean it up. Let's just separate a few things. Let's move this server facility here. Okay. And space is good because these graphs can get messy very quickly. So there's that piece of intelligence, and this is that server, and it's talking to these firewall endpoints. We're just recreating that same graph we had before. And there's the external one, so I'm just going to click on that and use the Apple key in order to select multiple things. And then I'm just going to expand all of these, and this is going to show me now how those firewall logs connect up to my internal facility servers to see what's going on here. And sometimes it just requires, you have to move these around a little bit to kind of get a feel for what's going on. I like to bring things out that are important, or something like this. This is the system, it's an application server. I don't really care about that. So I can hide it. So I can just right click on it, and it's called dismiss. So if you dismiss it, it just drops it off. So we know it's a help system. I'll leave that on there. Just kind of tidying up a little bit. But we can see here, there's those two firewall issues, or the internal firewall that's connecting to this IP address. So we might want to know more about this particular system. But when it's reasoning, it's following these chains of logic through the system. So that's sort of one way to do it. As you bring more information into the graph, you could spread it out.